Okay, so here, if we're converting from degrees to radians, you guys remember how to do that? 80 degrees over 1 times pi radians over 180 degrees. Remember, 2 pi radians is a full circle, 360 degrees is a full circle. We just divided them both by 2 to reduce it a little bit. So instead of 2 pi and 360, we use pi and 180. The degrees will cross cancel out. Both 80 and 180 can divide by what? We're going to do 20 would give me 4 and 9. So 4 times pi radians is 4 pi radians over 1 times 9 is 9. So 4 pi over 9 radians. Make sense? Just a matter of cross-canceling and the fractions is all it is. Yes, sir.
You there would bring it down to decimal.
If you did like 0.44 pi or actually multiplied out the pi even, that works. I prefer it like this because technically, grammatically, that's more correct. That's the way it's preferred in math. But if you took it down to a decimal, I could live with that. It'd be like 1.4 something radians. What's that?
1.396.
1.396
Yeah.
radians? Okay. So let's say you have 120 degrees. You put that over 1. That's going to be times pi radians over 360 again. Once again, the degrees will cancel out. 120 and 360 can both be divided by 120 to give me 1 and 3. So 1 times pi is pi, and 1 times 3 is 3, so it's pi over 3 radians. So you might have like 1.05. Yes, sir.
Why is it over 360 now?
Well, that should be 180, shouldn't it? That would change this. This would be 2 pi over 3. Because that'd be 2 and 3 because they both divide by 60, not 120. Thanks, Mike. Good catch.
Would it have, if it was 360, would it
Have to be 2 pi. Yeah. So 3, we're going to do this 3 pi radians over 4 is the way we're going to write that. Times pi radians on bottom, 180 degrees on top. So the radians cancel, the pi's cancel. 3/4 times 180 is 135 degrees. Pi over 5. I'll put the pi radians on top again. So pi radians, 180 degrees. The radians cancel out, the pi's cancel out. I have 180 over 5, which is 36 degrees. Anybody have all 4 of those correct? Anybody have no clue how to get any of them? It's just our measurement conversion deal here, the 180. 180 degrees equals pi radians. So it's just a measurement conversion like we did a lot of last semester. So if you're really getting stumped with them, Nick, just go ahead and do the decimal version. Like 80 degrees, do like this, 80 degrees over 1 times pi radians over 180 degrees. So you're just going to do this. On your calculator, you do 80 times pi divided by 180. Gives you 1.396 radians. That's fine, just like that. Does that make more sense? So you're multiplying across the top, dividing the bottom. Could you find the length of piece X there? We went over this a lot last semester, but we did it mainly as arcs, where we were hitting it perpendicular and splitting the chord down the middle. But remember, when we have 2 chords that intersect, the product of the pieces is the same between the 2 chords. So 4 times 9 has to equal 3 times x, because those pieces are in the same chord. So 4 times 9 is 36. Divide by 3, x has to be 12. Make sense? So what if I have a radius of 5 inches? And this is a tangent, and it's 12 inches long. I want to know this length. Why can I do that? Why can I do that? Because we know that the radius forms a 90-degree angle with a tangent. So this is just going to be the square root of 5 squared plus 12 squared, which will give us 13. So 13 inches is that distance. Looking familiar? What's that? Sadly? Try to convert that into degrees for me, just to give you a little extra practice. See if you can do it. I know. So if you're really stuck on this one and the cross-canceling doesn't work for you, you do have to cross-cancel the radians, but you can do 3 times pi times 180, then divide by the 4, then divide by the pi. And it does give you, oops, I didn't get pi in there right. It does give you 135 degrees, should come out. So you can just do that on the calculator if you don't like dealing with the cross-canceling. Any questions? Okay, well, the good news is you get to show me what you know. Let's take a peek at this problem I gave you, and let's see what we know.
Is this the same problem?
This is the same problem on your worksheet. Yep.
Hey.
Oh,
What's your first question that you're asked?
what's GF?
What is GF?
And GF is 6 centimeters.
6 centimeters. You got her.
OG is 3 centimeters.
GF is the diameter, so it has to be twice the radius. What's the second thing you're asked to find?
Angle of EDA.
Angle EDA?
EDA.
EDA. So that's this angle right here, which would be half of whatever this arc is from here to here. Well, we know this is 120 if we just knew this piece. How could we possibly know that piece? Well, if this is 30 degrees, that's a right angle, that's a right angle. This is 150 degrees, making this 30 degrees.
Would you look at that?
Which makes this whole arc here 120 plus 30, or 150 degrees. Which makes this angle half of 150, or 75 degrees. How many of you found 75 degrees for that?
I was right. I was getting.
What's the next thing we're asked to find?
Angle EHF.
EHF. EHF is this angle right here. Well, we know this is 30 here. So we know that this arc here is 100 degrees. If we know this arc, that angle is the average of those arcs. Do we know arc EF?
Yeah, no, I did say that.
Do we know arc EJ? EJ has, well, yeah, this has to be 30 right here, doesn't it? Or 60 right here. Because that's off of, this is a diameter here, so that has to be 180. So if this is 120, that has to be 60. So we have 100 degrees and 60 degrees. So 100 plus 60 divided by 2 is 80 degrees. Where?
30 plus 75.
No, this is 70 degree arc.
That is 90 degrees.
75 is the angle, not the arc.
Oh, oh.
What's that?
That's supposed to be a 90 degree.
This here?
Yeah.
Yeah, that's 90 because it says they're perpendicular.
So all four of those. I think.
So all four of these are 90 degrees here, 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 and here.
That
Little
angle.
square.
This angle's not quite 90. It has to be smaller than 90. Because it's off to the side of it. So yes, that is an 80 degree angle there. What's the next thing we're asked for?
Circumference of the circle.
Circumference of the circle, I'm assuming you can find, is just 6 times pi. What's the next thing you're asked for? It's like 18.85 or something like that.
The arc of ADF.
ADF.
Yes.
So arc ADF. This is from here, ADF. Well, that's a diameter. That's 180 minus the 30, so that's going to be 150 degree arc. So next thing we're asked for. What's that?
Yeah.
Length EF or arc EF?
Arc and centimeters.
Arc EF in centimeters?
Yes.
Well, it is 60 degrees. So it is our circumference. 60 over 360 equals that over 18 point what?
849.
85. Cross multiply and divide, you'll get that as 3.14 about. It's basically pi, yeah.
Next, we're trying to find the area of sector of GOA.
Area of sector GOA. Well, that's going to be the area of the whole circle. Well, that's 30 degree sector, so it's 30 out of 360 equals that area out of the area of the whole circle, which is pi times 3 squared.
Wait, where's the 3 thing?
Radius of 3. You guys get the picture?
No. I mean, sort of.
Sort of. What's next?
Angle of OFC.
OFC?
Yes.
OFC. OFC. That angle has to be right angle. It's a radius to a tangent. What's next?
KJ.
The length of KJ. If this is 2.5, this has to be 2.5. So KJ is also 2.5. Because if a radius hits a chord at a right angle, it cuts it in half as well.
And then angle of
ABD. ABD. So this angle right here, this is 70 degrees. This is 150 degrees, right?
Right.
So that angle is 150 minus 70 over 2, otherwise known as 40 degrees. Is that it, or is there one left?
Yeah.
KF, length KF?
Yeah.
KF right here? Well, you can find that off of this. You know, this is 3 and this is 2.5, so you can find that. So I'm going to draw that down here. You know, this is 3, you know, this is 2.5, you know, this whole thing here has to be 3. So if you find this, you can subtract it from 3. That is going to be the square root of 3 squared minus 2.5 squared, which would be the square root of 9 minus 6.25, or the square root of 2.75.
How did you get 3 for EV?
It's the radius of the circle.
It doesn't go to the center. O is the center. O is the E. Oh,
So wait, hold
you're
on.
making one time.
I'm going to make my own triangle here.
Sorry.
The figure 4 there. So that's 3 minus the square root of 2.75. 1.34 I get.
Yeah,
Any others? Is that it? That'd be all? Okay. Well, the good news is we are done with our unit, which means I'm going to be nice and I'll send home the test with you. Right.